All right, the first thing I'm going to do is go over this bell work so you make sure that you have all the correct answers and get 100 on it. So to find the missing measure of, to find the measure of the missing angle in the triangle, you have 3 of them. So 58 plus 74 plus x, because we don't know that one, equals 180. Then combine like terms, 58 plus 74, let me get my calculator. Oh, sorry, y'all. Is 132 plus x equals 180. And then we'll subtract the 132 on both sides and get that x is 48. Or, sorry, the measure of angle C is 48. Okay. An exterior angle of a triangle measures 115, and one of the non-adjacent interior angles measures 48. So what I've seen some kids do is they draw the triangle and the exterior angle. So this is 115. One of the non-adjacent is 48. This one's x. So remember that the two non-adjacent angles add to equal the exterior. So what you end up doing is just subtracting 48 from 115. To get that x is, or that other angle is 67. Okay, and number 3, you have a triangle DEF, and then it gives you 1, 2, 3 angles. And we know that 3 angles inside a triangle add to equal 180. So that's where I'm getting this equation from. And then you just solve, combine like terms. That's 8x plus 10 plus 20 plus 30 is 60 equal to 180. Subtract 60 from both sides. You get 8x is equal to 120. Divide 8 on both sides. And 120 divided by 8 is 15. So x equals 15. It says find the measure of each angle. I don't really care for that. But you would just plug it in. So you do like 4 times 15 plus 10, 3 times 15 plus 20, 15 plus 30. Okay, that's what you do. All right, this one, number 4. In a triangle, one angle measures 3 times the smallest angle. The third angle is 12 more than twice the smallest angle was the measure of the largest angle. So clearly, since it didn't say anything about the smallest angle will be x. So what I'm going to do is put x over the smallest angle. So then I can read it, okay, starting back at the beginning. In a triangle, one angle measures 3 times the smallest angle. So 3 times x. Plus the third angle is 12 more than twice the x. So 2x plus 12. And then, of course, we have the last angle, which is x equal to 180. Okay, so the first thing we have to do is solve for x. So 3x plus 2x plus x is 6x. Plus 12 equals 180. Subtract 12 on both sides. And we get 6x is equal to 168. Let me double check that because I don't want to get it wrong because that's kind of embarrassing. Equal 168. Then divide both sides by 6, and x equals 28. But they didn't ask for x, and if you look at the answer choices, none of them are 28. So if you go back and read the problem, it asked that to find the largest angle. And it didn't say which one was the largest, so what you have to do is plug in and see which one just gives you the biggest number. So we'll do 3 times, oh, let me do that. We'll do 3 times 28, which is 84. We'll do 2 times 28 plus 12, which is 68. And of course, this one will just be 28. So therefore, 84 was the largest. The answer would be B, 84. I don't know why I put parentheses. Okay, so let's continue and go into notes now. This lesson is super easy if you understand the vocabulary behind it and then just label. Okay, so in an isosceles triangle, remember you have two eyes. So isosceles means you have two congruent sides. The two congruent sides in an isosceles triangle are called the legs. Okay, so we would label AB as a leg, BC is a leg. The angle where the legs intersect is called the vertex angle. So where the legs intersect would be point B right here. So that's a vertex. The side opposite the vertex angle, which is also like the one that connects the legs. Sorry, let me repeat that. It's the line that connects the two legs. That's the base. And the angles along that base, so for example, A and C, are called the base angles. And it's super important that you are able to recognize the legs, the base, and then the base angles. That's because the isosceles triangle theorem basically says the two base angles of an isosceles triangle are congruent. Okay, just to like put it in simple terms, the base angles in an isosceles triangle are always congruent. So in that case, because line AB is congruent to line BC, because the legs are congruent, then the two base angles, angle A is congruent to angle C. Okay? So for example, number 1, line JK is a leg, line KL is a leg, and that's because they're congruent, which means JL is the base, which means angle J is a base angle and angle L are base angles. Well, since they are base angles, they are congruent. So angle L is 68, which means angle J is also 68. And now we have a triangle, and we're just missing one angle. So remember, all three angles inside a triangle add to equal 180. So then we combine like terms. 68 plus 68 is 136. Plus x is equal to 180. Then we subtract 136 on both sides and get that x equals 44. Second equation is 44. And if I did that properly, then 44 plus 68 should add to equal 180. And number 2, line CD is a leg, line DE is a leg, which means CE is a base. And again, I know these are legs right here because they are congruent based off those symbols. Okay, and remember the two angles along the base, in this case, C and E, are congruent because they're base angles. Now, the problem is that we don't know them, okay? Because they are congruent, we are going to call them X. So since C is X, E can also be X since they're congruent. Well, now I have three angles in the triangle, right? So we're going to add them, 106 plus X, and equal it to 180. Bring down the 106. X plus X is 2X, equal 180. Subtract 106 on both sides. We get 2X is equal to 40, nope, what am I saying? Is 74. Divide both sides by 2, and X equals 37. So C is 37, E is 37. Okay, number 3. They actually don't tell you what two sides are congruent. It tells you this one's 12, but then they don't say anything about these. And remember, you never want to assume. So the two things they say are congruent are angle X and angle Z. So this is where the converse of the isosceles triangle theorem comes in. Basically, it's like the flip-flop or like vice versa of this one right here. So this is when they tell you that two angles are congruent. And because you know that two angles are congruent, you know the two opposite sides are congruent. So AB will congruent to BC. So in this case, okay, because these two angles are congruent, this is a base, right? Because remember, the base angles are congruent, which make these legs, and the legs are always congruent to each other. So YZ is 12. Okay, then we have to find angle Y. Well, this one's not too hard. It's just a triangle angle theorem where all three angles, so X plus 77 plus the other 77, adds equal 180. And then we do X plus, that is 154, I think. Let me double check. Yeah, 154 equal 180. Subtract 154 on both sides. And so X equals 26. So therefore angle Y is 26 degrees. Okay, let's go to number 4. They don't really tell you anything. They said find the value of each variable and then tell you that these are congruent. Or remember, the legs are congruent, which means this line is a base, which means these are base angles, and so these two are congruent. Let me change color. These two angles are congruent. So 5x plus 9 equals 8x minus 30. Okay, solve for x on your own. If you don't, then I know you actually didn't listen to me, and that would make me very mad. Okay, if you don't solve for x on your own, then I'm not giving you points when I come back next class. Okay, number 6, it doesn't tell you the sides are congruent, but it tells you that the angles are congruent, which means these are base angles, which means this is a base, right? So therefore, this is a leg and this is a leg, which means they are congruent. So 15x plus 7 equals 23x minus 17. Again, solve for x on your own. If you don't, I'm not giving you points. Yep, and then go to the next page. All right, listen, read number 8. It says in triangle RST, if line RT is congruent to line ST, and then angle R is 9x plus 2, angle S is 13x minus 8, and angle T is 17x plus 1. Listen, they give you 1, 2, 3 angles inside that triangle. Remember, all 3 angles inside a triangle add to equal 180. So you really don't have to do anything difficult on this one. Okay, there is another way to do it, but as long as you understand this, you'll be good. Okay. Solve for x, please. But number 9, it says in triangle DEF, if angle D is congruent to angle E, and then if you look, it says line DE is x plus 4, line EF is 4x minus 8, and line DF is 7x minus 35. The problem with this is, 1, they are not angles, so therefore we cannot add them to equal 180. And 2, it told us that 2 angles were congruent. So what we have to do is to draw the triangle, label it D, E, F, then label what they give me. So they say angle D and angle E are congruent, right? Which means this is a base, this is a leg, this is a leg, and so therefore EF is congruent to DF. And the reason why I know this is a base is because it's the only line where 2 of the angles are congruent. So that has to be the base. Okay? Well, since you know that EF is congruent to DF, we're just going to set these two equal to each other. So that means 4x minus 8 is equal to 7x minus 35. Okay, we solve for x. I'll solve for x on this one really fast. 3x. Ooh. 27. X equals 9. Okay. So then equilateral triangles, remember equilateral means all sides are congruent, and that's because the angles are congruent. So because the angles are congruent, we know line AB is congruent to line BC, which is also congruent to line AC. Okay? And let's say I only told you that these were congruent, then you would know, like, okay, well, because the sides are congruent, then the angles are also congruent. This is a cool little fact. It's pretty neat. Okay, number 11. Does it tell you all the sides are congruent? No. I don't see any marks. It doesn't tell me it's an equilateral triangle. All I see is this 9. This is blank, right? It doesn't even tell you that all the angles are congruent. It just tells you right now 2 of them are congruent. But let's see if we can find angle C. So 60 plus 60 plus x equals 180. 60 plus 60 is 120 plus x is equal to 180. Subtract 120 of both sides. X equals 60. Well then, therefore, all the angles are congruent, right? Because they're all 60. So since all the angles are congruent, all the sides are also congruent. So AB is 9, BC is 9, and AC is also 9. Okay. And number 12, it says that all the sides are congruent. Well, we know since all the sides are congruent, then all the angles are congruent. But if you look, it actually doesn't ask for any of the sides. It only asks for the angles. But they tell us nothing. Okay, however, a triangle is 180 degrees, right? And there are 3 congruent sides. That means we could divide it by 3, and all the angles are 60. Which is so interesting, because isn't that exactly what happened on the last diagram? And it's not a coincidence. Okay, every angle, you better be writing this down, in a equilateral triangle. I spelled equilateral wrong, didn't I? That's embarrassing. Equilateral triangle. Every angle in it is each 60 degrees. Okay, so number 13, it says if PQR is an equilateral triangle, that means all the sides are congruent. Solve for both x and y. Well, I would solve for y first because all these sides are congruent. So really, you can pick your favorite 2. My first block picked 9y plus 1 is equal to 14y minus 59. It doesn't matter which 2 you pick. Okay, subtract 9y. Add 59 to both sides. Oop. Those cancel. 60 equals 5y. Those cancel. Divide by 5, and y equals 12. Okay, but then x is an angle. I know it's an angle because it has a degree symbol. Okay, and they don't tell me any of the angles. Well, remember, every angle in an equilateral triangle is each 60. That's ugly. Is each 60 degrees. So therefore, angle P is 60. Angle Q is 60. And angle R is also 60. Well, angle R is also 7x minus 3, right? So what we get to do is 7x minus 3 is equal to 60. And then just solve for x. So we add 3 on both sides. 7x equals 63. Divide 63 by 7. And x equals 9. So y equals 12 and x equals 9, and that's it.